What's up, Algebra 1? Catlin here with your cool down help for lesson 7. We're starting to look at these negative exponents and how they affect our exponential functions. And we have one here about a fish species inside this lake. The equation p equals 5,000 times 2 to the power of t represents the population of an invasive fish species in a large lake t years since 2005, when the fish population in the lake was first surveyed. So 2005 is kind of like our reference year. It's our year zero. And if we look at the equation that's given to us, it's in the form that we recognize that we've been using, with 5,000 being our starting number. This is how many fish were there that first year it was surveyed. And then this is our growth factor. So it's growing by a factor of 2 yearly. So it's doubling every year, what we get from looking at the equation. That should be information we can look at now and know. So as they ask us these questions, we should be able to answer them. Since it was first surveyed in 2005, the population of the lake in 2005 was 5,000, where it started in that year zero of the first survey. So we know that in 2005 there were 5,000 fish because of the way that they wrote this equation. For number 2, for this model, what does it mean when t is -2? Well, T right here is representing years since 2005. So when it's 0, it's 2005, which is why that's 5,000. And every subsequent year, 1, 2, 3, 4, 5 would be like 1 would be 2006. When T is 2, it'd be 2007, so on and so forth. So going backwards with those and making those negatives goes back into previous years. So if 0 is 2005, then -1 would be 2004, and -2 would be year, or it would be the, let's rephrase that. Let's say it would be the fish population in that year. So, the fish population in the year 2000, and 2 years before 2005 would be 2003. For t equaling -2, is the fish population more or less than 1,000? How do we know? Well, we got a couple of things that we could do. We could use the equation and plug it in and see what it equals. 5,000 times 2 to the -2 power. Now, we learned in class that whenever we have a negative exponent, we can rewrite that as being, this isn't going to change, still 5,000. We can rewrite that as being the reciprocal of the base. The reciprocal of the base is 1/2 to a positive same power. So 2 to the -2 power is the same as taking half and multiplying it by itself twice. These are the same values. And it makes sense since the population is doubling every year moving forward. Going backwards as years go back, it makes sense that they do the opposite of doubling, which is cutting themselves in half. So we would take 5,000, multiply it by half twice. So that would look like this: 5,000 times a half times a half. Now, half of 5,000 once is 2,500. And if we do half times 2,500, we get the answer here, which is 1,250. So we would expect there to be 1,250 fish in that lake 2 years prior to 2005, in 2003. And that's our answer for number 3, using negative exponents, their reciprocals as bases, to find out what going back in time would be equal to for a growth factor of 2. And that's your help for today. Hope this was uh, beneficial to you. We'll see you guys tomorrow, hopefully.